hear me? Am I on? No, we're not. Okay, are we on yet? On? No. Testing? 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 We did this before we started. Testing? Okay. Now I gotta figure out how to put this back in my clothes without exposing myself. Yeah. This is a first. There we go. Okay?
Yeah.
Awesome. Very good. Very good. So, before I start, I do want to say thank you. This is an extreme honor. I'm just so pleased and honored to receive this award. The cognitive science group here is just awesome. You guys are so lucky to have this program here that's putting all the different kinds of cognitive science together. I am really just so pleased and honored to receive the award. Thank you so much. So to start, we're talking about that it's all in your words. So what words am I talking about? So I know that you probably write reports, and you might even put those reports up in Dropbox, right? And if you don't put them on Dropbox, maybe you even put them on the cloud, right? Anybody here use the cloud? No, some people know better. Yeah, okay, but if you don't, maybe you post it on forums. Anybody? Maybe not so much, few, okay. And if you're not posting on forums, maybe you might be using Twitter. Anybody tweet? Come on, there's some tweeters in here. I know you're out there. And if you're not tweeting, maybe Facebook? Anybody? Facebook? Okay. Or even cell phones? You're probably not texting anybody, right?
Yeah.
Nobody's ever. Yeah, you're not texting. You're not texting. Okay. But if you're not texting, then maybe you use email. And maybe you even use Gmail, right? And when you're using Gmail, maybe you look off to the right and you see the ad that actually relates to the last 2 emails you sent. Like my student who happens to be a little bit concerned with drinking versus the other one who was more concerned with ballet. And I'm sure you've probably experienced this. And so you've probably heard this. It's just for commercial purposes, right? So it's okay. Yeah, it's just for commercial purposes. No problem. All right. What about the eye, right? The government eye. Okay, so who's watching you? And what do they hear? Oh, okay, so you probably have heard about Snowden. Did you hear about Snowden?
Yes.
Yeah. Okay. So who was Snowden? He was a CIA defense. He worked for the defense. He was actually a spy. And in 2013, he released documents to the press. And from those documents, the public became aware of tools being used by the government, like PRISM and Dishfire. And so each day, according to, guess what I use to gather my information? Yeah, scientists, Wikipedia. So yeah, I'm sure this, like, we've all broken down. So I looked it up on Wikipedia. Okay, so in fact, I think I copy and pasted. So I'm plagiarizing no less. So Wikipedia, Dishfire collects geolocation, business cards, financial transactions, border crossings, roaming alerts, and even each day. So that's a lot of information. And so, okay, Wikipedia may not be reliable. So let's look at a national security presentation that is, it was top secret. It's on the web. So it was top secret in 2011. So this is from a presentation that security gave to essentially potential operatives who were about to go in the field to tell them about what information could be potentially given to them and what that information is coming from. And essentially this gives the same information that I just gave you, just with lower numbers, because it was 2011. And so this is another top secret slide that you can find on the web from a presentation given by National Security Association that describes how this works and how different tools work together to gather the information and then process the information. And so this is a slide used by Top Secret again, presented by National Security Association in 2013, describing how all of these tools and companies that you yourself use, like Google and Yahoo, and as you can see in the list, Google, Facebook, Paltalk, YouTube, Skype, AOL, became a provider to the government for all of your information. And so this is the information that is provided to the government. And so let's actually listen to Edward Snowden. And one of the things he said is, it's no secret that U.S. tends to get more and better intelligence out of computers nowadays than they do people. When I heard about Snowden, I was like, yeah? You guys didn't know that this was going on? Because it was obvious to me. I had no idea, no one knew, that this was certainly going on. Let's watch what he says. Let's see if I can make it go. Let's hear some.
When I think about an instance that really just struck me as, oh my God, we can do this, and that we can do it to anyone, was that people at NSA, analysts, can actually watch people's internet communications, watch them draft correspondence, and actually watch their thoughts form as they type. As you write a message, an analyst at the NSA or any other service out there that's using this kind of attack against people can actually see you write sentences and then backspace over your mistakes and then change the words and then kind of pause and think about what you wanted to say and then change it. And it's this extraordinary intrusion, not just into your communications, your finished messages, but your actual drafting process, into the way you think.
So let's think about this, or the question that's posed. Is this true? So is this statement true? Can we take your language, take your process of typing, of producing language, and infer what you're thinking as you think it? So what can we get? What's easy? There are easy things. This is the easy stuff. They know where you are. That's easy. They know your nationality. They can know your gender, your race, your religion, basically what you generally do, your likes and your dislikes. This is the easy stuff. How do they get it? They get it from these sources of information. Clickstream. What are you pressing on? What sites do you go to? where your credit card use, your business cards. People use these business cards. Who do you interact with? So your social interactions. Your missed call, your text messages, emails, posts, phone. So all of these sources of information come together to provide this picture of you and you. Everyone in this room could be potentially identified using all of the information that is online now and available to the government. So, what about natural language processing? Who hasn't waited their whole career to play that song? Yeah. So there's the good, bad, and the ugly. Let's talk about the good. So, I made it go on all 3 slides. Yeah. Once I did that, I couldn't transfer it from computer to computer because it was too big. The file. Okay, so let's talk about the good. The power of natural language processing. So what is natural language processing? It's the process of taking features of language and using various statistical techniques and sources of information, primarily in linguistics, and putting them together by using various statistical tools. We do that for 2 primary purposes. One is the cognitive science. So if we have a cognitive science hat on, it's to understand language. Another reason for researchers to do this is more in the realm of artificial intelligence. So to simulate the understanding of language. There's also the generation of language. So, but it's more along the lines of AI, artificial intelligence, and to respond to the speaker. So natural language processing provides a variety of information about many different processes, cognitive processes, social processes, and it provides it at different levels. So it provides information about the words, it can get information about syntax, about reasoning, about affect, so emotions, what kind of arguments you're using, what kind of reasoning you're using. Are you using complex language? What kinds of words are you using? Are they words related to a story or to information? So we also use statistical techniques like latent. To do this, we use statistical techniques like latent semantic analysis. Latent semantic analysis is a tool that takes corpora of languages and scunches it down into a space and then compares sets of languages. And this was revolutionary in terms of our ability to do computational analyses of text that went beyond the words themselves. We have also built a tool that incorporates, to some extent, LSA, called Cometrics. And Cometrics does is it takes language and it extracts features of language related to the words, to the sentences, and to cohesion. So it is built to predict text difficulty primarily. So to build models of text difficulty and to extract features related to text difficulty. We have in our lab a suite of tools. Tools that we've built along the way that have different purposes for and roles in extracting different features about language. So for example, we have we have Luke. So Luke is a tool that we didn't build. MOOC was a tool that was built mainly gearing toward clinical psychology and psychological processes. And it extracts using bags of words various aspects like social processes, words related to family, pronouns, which were related to things having to do with how we process information, or even clinical things like if you're crazy, and things related to cognitive mechanisms, and so lots of different things are available through MOOC. We've also developed a tool, or we're actually still developing it, called WAT, which is the Writing Assessment Tool. And it is geared toward going beyond features related to text difficulty and looking at the quality of writing. And so we've added rhetorical cues and semantic relationships between bodies of text within essays and various other things so that we can better model essay quality. We've also got another tool that I want to mention is a tool called SIMLIP, which is Simple NLP, which is available online, available for people to build their own natural language processing tools. And so we give instructions, and you can go in there and build your own bags of words and do analyses that are highly predictive of many things. So very simple natural language processing tools are highly effective at predicting various aspects of language. So, there you go. That's what I was talking about just a minute ago. With the linguistic tool, let's look, what, and SIMLIP. So those are 3 tools that we have available. So let's talk about what information is available in your words. So our assumption is that words serve as proxies. The words are not the concept or the information itself. We do not believe that the words are representations of what you're thinking, or how you're thinking, or the quality, or anything, but they are proxies. They are links to those notions. But they serve as proxies to many different things: actions, skills, thoughts, affect. The list goes on. Natural language processing can inform things like intelligent tutoring systems. So as I mentioned, we've used it to assess essay quality. We've used natural language processing to drive feedback on essays. You can use natural language processing to assess the quality of an explanation. So if I ask you to explain text, then I can give you feedback on that. We've used it on free writing quality, on paragraph, and grammar and mechanics. Those are kind of the simpler problems. We can also assess mental states. So various people have done sentiment analysis, and you can inform whether someone is bored, if they're excited, if they are frustrated, and the list goes on. We can also assess individual differences. So we can assess your level of prior knowledge, your reading skill, your working memory capacity, whether or not you're persistent. The list, those are kind of the basic things we've done. And the list goes on. We can determine who an author is, so we can distinguish between different authors. We can assess the gender of someone and predict their proficiency in speaking. They're a foreign language speaker. If we have language that is spoken by people who are speaking English, but they come from different first languages, we can predict what first language what their first language was. We can predict let's see, text readability and text coherence I've already mentioned. So we can do a lot, and we've done a lot. We have many, many, many studies. doing this. So let me talk about how this works. If you have a text, we extract information about the text. So on the one level, we just use the words. So the words themselves are information. And we can use a bag of words approach, and you can count the frequency or the incidence of how many times those typical words appear. You can also use something called n-gram analysis, where you assess the frequency or how distinctive certain patterns of words are. And then you can also assess at the sentence level. Oh, I'm sorry, I forgot to mention. At the word level, we use both what's called latent representations and non-latent. So that is what's distant semantically and what is the word, what are the words themselves. Then we also assess features. So features of the word. We have the word, but that feature in and of itself that word has features. It may be more or less frequent. It may be more or less meaningful. It may have fewer or more associations to other words. We can also assess at the sentence level, we can assess the features of the sentence. So we can assess, for example, if their complexity. How complex is the sentence? How many words does it have? How many words before the main verb? And then at the text level, we can assess things like cohesion. So how do things link together? Is there a lot of overlap? Where is that overlap? Is it semantic? Is it the word level? Is it at the syntax level? Is it between sentences, between texts? So all of these features can be used to predict those things that I said that we could predict. So we put this all together and we apply machine learning. So various kinds of algorithms we can use. At the simplest level, we use regression analysis. So we can predict we have a dependent variable, and we have independent variable, and we use these indices to predict them. And then that gives us, we predict the outcome, and then we come up with algorithms, and then we test those algorithms on other sets. So in essence, what we're doing is we take language, we extract those features using various tools that we've put together, and then we create these algorithms that use the separate features. And then you actually build new tools that only extract the features that you need in order to use them within intelligent tutoring systems or within whatever system that you are trying to develop. So our context is one of our contexts is intelligent tutoring systems, where what we're doing is we are providing automated tutoring that is intelligent, meaning it adapts to the individual, and provides instruction. So provides instruction that's adaptive and automated. And one of those tools is called iStart2. iStart2 provides training and practice in self-explanation. So the goal of iStart2 is to teach students to explain text using comprehension strategies, like making bridging inferences and paraphrasing and making elaborations. And it does this using game-based tutoring, and then they practice generating the self-explanations, and they receive feedback. And in our studies, we've shown that iStart and its predecessors increase knowledge of and application of self-explanation strategies. It improves reading comprehension ability, and then the game-based versions help to increase and enhance motivation and engagement and persistence. So natural language processing in iStart, how does it work? Essentially, a subject self-explains a text, And then we apply a natural language algorithm that is based on, that uses both latent semantic analysis and word-based information. And then we extract a score that says, what is the quality of that explanation? This is a more complicated picture of how it works, where in ISTART we use a very hierarchical method where we first get frozen expressions, and then we extract whether or not it's relevant or irrelevant, and then we apply the various, we extract information about the words in the text, and we assign it a score. And so another tool that we've worked in is called the writing count. And the writing count is very similar, except it teaches writing strategies. And our goal was to provide, in essence, high school students and even early college students with training on what are the strategies you need to write a basic essay. So many students don't know even that how to generate information, how to structure an introduction or a body or a conclusion or different strategies for revising. So it focuses on strategies to accomplish those goals. And then another aspect of it is that students practice writing essays and they receive feedback on the quality of those essays that links back to the strategies that they have learned. And then they practice some more. So there are 9 modules. They get training in each of the kinds of areas of strategies, and they receive feedback. And so one of the aspects is on essays. So they write essays, they get feedback, and we've done many studies to assess the quality of essays or predict the quality of essays. So we have too many studies to really talk about at this time, but for example, one of the studies looked at, used information about the diversity of the words, so how many different kinds of words they use, about the frequency of the words, so essentially using bigger words, and then also on the complexity of their syntax, and they use more complex sentence structures. And this research has shown that in essence, students who write better, higher quality essays use more sophisticated language. Another type of study that we've done is to look at essay properties across time as they're writing. So we have one study where students wrote 16 essays, and we looked at how, for example, narrative cohesion and narrativity changed across those essays. And that takes us back to cometrics, which has component scores for variables like narrativity and cohesion. So we can take those essays and look at whether or not students are persistent, they use the same level of narrativity across essays, or the same level of cohesion across essays, or whether they adapt their cohesion levels. So do they use more narrativity for some prompts and less for others? And what we found is that more skilled writers are more flexible. So they will tend to adapt their level of narrativity to the prompt. We assume, we don't have evidence yet, that this is a function of their knowledge. So if you have more knowledge about something, you're going to use that information. But if you have less knowledge about that prompt, then you'd be more likely to use a story or more narrative information about your life. So another thing that we've done is we've looked at individual differences. So in essence, what we're trying to do is reverse engineer. One of the things that we're trying to do is called a stealth assessment. So one of the problems in educational interventions is if you collect too many individual difference measures, that takes too much time. And you're not going to be able to do that if you are doing an intervention in classrooms. And so we're trying to reverse engineer information from what they're doing during training and predicting the individual differences, which actually predicts various things on how training should occur. So for example, in one of the studies, we looked at working memory capacity. So working memory capacity, what my student did was she took essentially the features of the essays. She had a working memory capacity score, and she was able to predict, had an R-square of 40.46 by using the features of the language in the essays. And that included word frequency, the number of meanings of a word, meaningfulness of a word, and various other factors. But that information in the essay was related to their working memory capacity. What about forums? So how many have been in MOOCs, for example? Anybody? Cool. So MOOCs is hot, it's big data. And online courses are high. More and more schools are going toward using online courses. More and more schools are offering MOOCs, so massive online courses. And so one of the questions that we're looking at is social collaboration and social knowledge building. So we want to get an idea of how can we detect social knowledge building within forums, discussion forums, and then how does that relate to performance in courses? Eventually we want to know how can we intervene, how can we help the students build knowledge socially, if that's important. And so, for example, one of the courses we've looked at is a course that is being offered by Ryan Baker on educational data mining. So we're using data mining on a course about educational data mining. So 48,000 students signed up, and 13,000 watched at least one video, and 719 posted at least one time in discussion forums. And we analyzed the features of the language that was used in these discussion forums. Now, one of the things that people say about MOOCs is there's a small percentage of students who finish or complete or receive certificates. Now, my thought or response to that is that there were 719 students above 0 who received education on educational data mining. So although many people do not have the intent of finishing, many people did receive some education and information on this topic. And we need to think seriously about that and how to improve it. So we have one recent study that looked at the text features of this MOOC in discussion forums, and we looked at 320 individuals who had posted at least 50 words across these discussion forums. And our goal was to predict whether or not they had completed the course. So what we did is we extracted features of these discussion forums using simple ANOVA, and then we used discriminant function analysis, so another machine learning technique that would say which of the features are more important so that we could predict whether or not they completed the course. And so we found, and this is what's called a confusion matrix. And in the diagonal, what that shows is how many were correctly identified. And that shows that we had 70% accuracy of identifying, based on what they were saying, whether or not they completed the course. Now, a lot of the features that were predictive were about your writing ability. So in fact, if you go back to the essay quality, our essay quality algorithms, our main essay quality algorithm was one of the most predictive variables. So that's kind of not very interesting in the sense that people who wrote better did better in the course. And that's probably related to individual differences. But the point is we can detect that using the language that they're posting and using on the forums. So the language you use is related to many different things, including your knowledge, your skills, maybe how interested you are in the course, and many other factors that are going to influence whether or not you do or do not actually complete this course. This is another approach we've taken. This is an interaction graph. This is all the individuals in the course and how related they are in terms of their cohesion between their interactions. So it's a social network analysis, but it adds on top of that, again, going back to the cometrics tool or the analyses of cohesion, and we're looking at how people are building knowledge and how that's related to their performance in the course. Those red dots are the teachers. And so the people who are teaching the course, the instructor and the TAs, are centered to that process. The students are interacting with those individuals more than each other. And then there are some individuals who are on the fringes, who don't interact very much with others. And we can look at that using these tools. So, I said it's all in your words. But of course, I'm lying. It's not all in your words. And so, it's not all in your words. So what else is there? If our goal is to predict outcomes, and a lot of us are interested in predicting outcomes, some of us are interested in predicting educational outcomes, but some of you are interested in predicting other outcomes. So in order to do that, we need interdisciplinary methods. We need to combine information. We need information about behaviors, about language, about choices. We need to combine learning analytics with natural language, with behavioral methods, with psychometric methods, with many different methods. So in order to do that, we have to have, in order to move forward on this, we need to have automatic detection. Automatic detection is going to allow us to collect this information and then combine it together so that we can build these models. And then we also need to build dynamic models. We need to build models that take into consideration change over time. So understanding learning in complex social environments, how can we do this? Well, NLP can provide a key ingredient. So that's one thing I'm trying to sell, is that natural language is a key to predicting outcomes. However, I don't think that this is the bigger picture or the whole picture. We need language. We can add traditional measures like surveys and accuracy. We can also look at telemetry data, which is kind of log data of what people are doing, clickstream data. We can look at persistence, how long you stay in a system. You can look at actions, what you're doing behaviorally, your gestures. And you can look at social interactions. I think looking at social interactions is a large key to solving this problem and in predicting outcomes. So in terms of a classroom, it's a social process, a dynamic process. You have the individual, you have individual students interacting in a classroom. You have a teacher, And this happens over time. And what we're moving toward in the field is combining information from all of these sources so that we can build more complex models and more complete models to have a big picture. So we can go back to the good, the bad, and the ugly. And there are clearly individuals who are not doing this for scientific purposes. There are individuals out there who are the corporations. And those corporations, companies, and government, they do not need ethical permission or IRB in order to collect that information and to analyze it. However, and then obviously, even by scientists, natural language processing, natural language, information about language can be misused. So we need to be careful about the identity of individuals when, as researchers, we are examining this data. But we need to also look at who it is. So I've categorized this as very black and white, the bad and the scientist. So the companies versus the pure researchers and scientists. And the companies and are obvious, and the government. What they're doing is, what they're trying to do is identify the individual, who the individual is, what they're doing, what they want, what they can be sold, what they want to buy. The difference is most researchers are not trying to identify the individual. They're trying to describe group behavior. They're trying to predict individual behavior afterwards. So I want to take my information that I collect about individuals who I do not want to identify, and then I want to predict your behavior in a tutoring system. So an individual's behavior in a tutoring system, then I want to predict it. But when I'm collecting information about language, I want to hide who an individual is and essentially gather means about groups of individuals. So my point is that NLP doesn't target people do. And before I end, I do want to thank my lab, and in particular, Laura Ellen, who has been very helpful in completing this talk and then to a lot of the research that went into this. And I want to thank you. I'm very, very happy to be here. I'm very honored to receive this award. And, oh, that's it. Thank you.